Okay, so triangle congruence. There's 5 different ways that I can prove two triangles are congruent. And we call these our triangle congruence criteria. Or we could say triangle congruence postulates, but there's 5 of them. The first one, if I have 3 sets of sides that all match, 3 pairs, we call that side, 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 or S, S, S. And this is my example here. The 1 hash mark matches with this 1 hash mark. You know, the 2 goes with the 2, 3 and 3. This tells me that all 3 pairs of sides are congruent. So if I gave you the measurements for 3 sides, there's only one way you could put those together and make a triangle. Or my second criteria, my second postulate, here I have 2 pairs of sides that match. That's what these hash marks tell me. And the angle between them also matches. So again, if I gave you all these measurements, the 2 sides and the angle between them, there's only one way you could set those up to build a triangle. So these would have to be congruent. I could prove that these are congruent. My third example, here I'm showing that this angle and this, these both correspond, or the double arc, this and this, that tells me that these correspond, and the side between them, these both match. So this is angle, side, angle congruence. If I give you 2 angles and the side between them, again, there's only one way that I can set those up to build a certain pair of triangles. My next example here, I've got this angle and this angle match, the double arc, these match, and then a side with the hash mark here, this side and this side. So if I have angle and then an angle and then a side after that, or I could say a side and then an angle and an angle. These both mean the same thing, they're just reversed. Again, I can prove that the 2 triangles are congruent if I have that much information. And the fifth one, this is only for right triangles, but if you have 2 right triangles with this 90 degree, and here if their hypotenuses are the same, so this hash mark and this hash mark, that tells me the hypotenuse, or the longest leg, is the same. And if I have another leg, the double hash, if these 2 legs are proved to be congruent, this is HL, or hypotenuse leg. So only these 5 work. I can only use these 5 for congruence. If it's not one of these, then I don't have enough information to prove that it's congruent. So the most common mistake here is using angle, side, side, or some teachers say side, side, angle, so that you don't have to write a bad word. But here, I'm going to write angle, side, side, and put a cross through it just so you remember it. Geometry has no ass. It just doesn't work. It's not going to make a triangle. If I gave you an angle, a side, and a side, there's more than one way that you could put those together to make a triangle. So this just doesn't work. It's got to be one of these 5. Let's do some example problems here. So here I'm going to ask you, for each set of triangles, match the congruence criterion, or I could say postulate, that follows from the given information marked on the triangles, and tell me the transformation that mapped one triangle onto the other. So this first one here, I can tell that side BC is congruent to side CD. That's what these hash marks tell me. And the double hash tells me that AC is congruent to CE. So here already I have kind of 2 pairs of sides. I also know that this angle and this are vertical. These are vertical angles. So here I have side, angle, side, SAS. What transformation map these? You're probably thinking reflection. It kind of looks like this reflected over here. But if you look at where the hash marks are, it looks like this rotated, right? These are rotated. So this would actually be a rotation, even though it kind of looks like a reflection. You got to just look at where your hash marks are. The next one, so here I have sets of hash marks again for this side, AB, side ED. The double hash mark on AC corresponds with DF, and then the triple hash mark tells me that BC corresponds with EF. So here I have 3 sets of corresponding sides. We call that side, side, side congruence. Here it looks like there was a rotation, and also it kind of translated over, but we're just going to notice the rotation here. That's kind of the biggest thing that happened. What about this last one? So here I have 2 right triangles, and you kind of remember there's only one that works for right triangles. This hypotenuse and this hypotenuse, they have the same hash mark, so they're congruent. And there's also this shared side right here. So this is shared with both. We call that a reflexive side if it's shared with two reflexive. Let me make sure I spell this the right way, reflexive. If I have a shared side or a shared angle, that's called reflexive. So here, the green hypotenuses are the same. The red side is shared, and it's right triangle, so this is HL, hypotenuse leg. And here I can tell these reflected over. These reflected. Let's do just a few more examples. Same kind of thing here, but I'm just changing out my examples. For these pairs of triangles, this symbol and this symbol just tells me that these angles are the same. They're congruent. Or here, this star and this star, if I just see the same symbol, it tells me that those angles are the same. So here, angle, angle, and then I have another shared reflexive side. So this gives me angle, angle, side, or you could say side, angle, angle. It looks like it's not one of my choices, so I'll just write that in. Side, angle, angle is this one. Or you could say angle, angle, side. Here again, it kind of looks like a reflection, but notice that where your markings are, this kind of rotated to there. This kind of rotated over here. So a little bit of a trick question here. This is rotated, and I had to write in my answer choice because they didn't give me the right one. For this, I have a matching angle, a matching side with these hash marks, and then the double hash mark for this side. So here I have angle, side, side, which, remember, that's not one of our 5, right? Geometry has no S. That's not one of our 5. So these, I actually cannot prove that these are congruent. I can't prove it. Even though they look like they are, just by kind of eyeballing them, I can't actually prove it. So there's not enough information here. And my last one, this double arc by K tells me that that's congruent to A. The single arc by this angle B tells me that's congruent to this angle over here. So already I have angle and angle. Notice there's also a shared side. So BC is shared with both of these triangles, right? This right here. We call that a reflexive side. This is shared with both. So this is going to give me angle, angle, side. Again, that's not one of my choices, so I'll just kind of write that in. Angle, angle, side. And it's not a reflection. This is, again, a rotation, even though it kind of looks like a reflection. It's a rotation. Okay, so that's just a few examples of what this could look like. These are our 5 triangle congruence criteria, or we could say postulate. Again, it's got to be one of these 5. If you don't see one of these 5, we don't have enough information to prove.